This is May, June 2024, paper 1-2. Question number 1 says, what is a scalar quantity? So it's very simple. A quantity without the direction, which is option C. A quantity that does not require a unit. No, units are always required. Either it's a vector quantity or a scalar quantity by two perpendicular components, that is of a vector quantity. A quantity without a magnitude, again, anything that is without a magnitude or a unit is not a quantity itself. So C will be the answer. Question number 2 is from uncertainties and percentage uncertainty. He says X has an uncertainty of, or percentage uncertainty of 2%, Y has 4%. Now he says that W is a formula, or W will be something that is calculated by using X and Y, and the total percentage uncertainty in W is supposed to be 8%. Okay, fine. So let's figure out which formula would that be. So in option number A, if we had to make the formula for the error in W, that would have been percentage uncertainty in X plus percentage uncertainty in Y. Or to put in plain perspective, that would be delta X divided by X plus delta Y divided by Y. So we can see that these percentages are directly being added together. So this will be 2 plus 4%, which will become 6%. So this is not our answer. In option B, again, we're going to get 6%. The constant value of 2 has no percentage uncertainty because it's a fixed value. We know for certain that it is 2, so it's not contributing to any errors whatsoever. In question number, in option C, we have X divided by Y square. So if you were to solve this in terms of percentage, that would be delta X divided by X plus 2 because of the square multiplied by delta Y divided by Y. Now this delta X over X is given to us as 2%, which is 2% plus 2 because of the formula of power rule, and then we have the error in Y, which is 4%. So this will be 4. So this becomes approximately 10% total error, which is again not the option. So by elimination, we have already reached option D, but for the sake of understanding, let's solve this. So we have delta Y over Y plus 2 times delta X over X. Now this has already been given to us as 4%, which is 4% plus 2 into 2% error of X, which is this one. So this comes out as 8%, which is going to be option D. Question number 3 says that a football is kicked vertically upwards in air and it is experiencing air resistance. So we have to include drag in our question and the resultant force acting the ball as it moves vertically upwards. Okay, fine. So what's happening to the air resistance and what's happening to the resultant force? First thing first, the air resistance is going to decrease. Why? Because as the ball moves upwards, because of the gravitational deceleration and because of the air resistance drag, which always opposes the motion of the object, if the ball is moving upwards, drag will be acting downwards. So since both of these factors are acting downwards and because of the drag as well, we can say that the speed of the object is decreasing. Why this information is important? Because drag depends on speed. If the speed is decreasing, then the drag would also be decreasing, right? So option C and option D are not possible because air resistance is supposed to decrease because of the decreasing speed. They are interdependent. Now moving on to the resultant force, let's make the equation for the resultant force. Since on this object the weight is downwards and the drag is also downwards, right? So the resultant force equation becomes W plus drag, or weight plus drag equals to MA. Right? Because they're both acting in the same direction. That's why we are adding them together. If you don't like this, what we can do is minus W minus drag equals to MA, then it will call for deceleration. But again, if they have the same sign, they're eventually being added together. So no matter what perspective you look at it from, they're both being added together. Now let's consider only this part. So the resultant force is equal to weight plus drag. So what's happening to the value of weight? Is it changing? The value of mg does not change throughout the motion. So it is not dependent, or the resultant is not dependent on the value of the weight. So drag, is it decreasing? Yes, we decided that because the speed is decreasing, the drag is also decreasing. So when the drag is decreasing, the total resultant force, or the total sum of this value, will also be getting less and less with the passage of time. So the resultant force would also be decreasing. So this option will be resultant force decreases. So option A will be the right answer. In question number 4, we have which statement is not correct. Okay, let's consider all of them. Acceleration can be determined. Yes, this is correct. The gradient of the velocity time graph is acceleration and the area under the graph is actually the displacement. So this statement is correct. Acceleration is the rate of change of velocity. This is also true because acceleration is equal to delta v by delta t. Displacement can be determined from the area under the graph. This is also a true statement as explained over here. This is also true. Velocity is the rate of change of distance. No, it is rate of change of displacement, not distance. So this is what is not correct, which is false. Moving on to question number 5, we have a system in which we have a length of column, a feather and vacuum. We know this from an experiment that we do in O-levels as well, or read about it, that if a feather and a piece of brick or a very heavy mass is thrown or released in the presence of vacuum, then they fall at the same time with the same acceleration and same velocity, and everything else is same. So primarily the vacuum is stated because of that, because they want you to know that the acceleration will be constant. So vacuum calls for the idea that the acceleration will be constant. There is no drag, so there will be no reduction or increase, or there will be no involvement of the drag in terms of resultant force and acceleration. He says the time taken for t to fall from top to bottom is t, for the sake of example, right? Takes time t to fall from top to bottom. How far does the feather fall at half the time, right? So let's try to solve this. So previously, or step 1 would be to use the equation of motion s equals to ut plus half at square. Now we can see that it is falling from rest, so the first factor, which is initial velocity versus time or multiplied by time, will become 0, and s, which is the displacement, is actually the length L. So this is L equals to 1/2 into acceleration into t square. Now since to cover the whole distance it takes a time total of capital T square, so let's replace this t square with a capital T square with a 1/2 and L equals to this. Now acceleration will be equal to 2 times L divided by t square. So this is our acceleration, which is going to be considered constant because of the vacuum. Okay, moving on to the step number 2, because we want to find out the length, the distance, how far it is going to go. So we have an equation, exactly the same equation that we used over here, which is this one. Let's use it again. So L is equal to 1/2 a t square. So L equals to 1/2 into the acceleration, which is constant, 2L divided by t square, into the time given for this object to fall down. So what time did we allow it to fall? We allowed it to fall for 0.5 seconds. So 0.5 t will be the time. Now once you solve this whole system, you will simplify it down to this number, which is going to be 1/4 L, which is 0.25 L. Option B is the right answer. Question number 6 suggests that this is the motion of an object. Okay, a car traveling in a straight line. He says how far does a car travel when the brakes are applied? And the brakes are applied from T1 to T4. Very simple, straightforward question. So from T1 to T4, we're supposed to find out the area under the graph, because velocity time graph, for the velocity time graph, the area under the graph gives us the displacement, all right? And since it is moving in a straight line, displacement and distance will be exactly the same things. You can solve it by 2 ways. You can either divide this question into 2 parts. You can use half into BH for this triangle and length into breadth for the rectangle. But I believe that this will take more time because we don't have the definite cutoffs exactly at this point, or at this point we'll have to count the number of boxes. So for me that is a bit inconvenient because I feel that it will take more time to solve it this way. So on the other hand, we can use a parallelogram method. That will be 1/2 into the distance between the parallel lines, which is 4 minus 1, 3, right? This will be 4 minus 1, the gap between the parallel lines, and these are the parallel lines that we're considering, multiplied by the sum of the 2 parallel lines. So the sum of this will call for, this is actually 22, this value, and this is a value of 8. So this will be 22 plus 8. So this answer comes out as 45 meters, which is option B. Again, I remind you, you can divide this into 2 parts as a triangle and a rectangle and solve it the other way around. Question number 7, he says that 2 satellites collide inelastically. So the kinetic energy will not be conserved, but momentum is always conserved. That is the rule for inelastic collision. He's asking you about what's going to happen to kinetic energy and momentum. So kinetic energy will be reduced. Yes, it will not be conserved, but the momentum is always conserved. So this will be option C. This is actually a fact-based question. This is actually part of the definition of inelastic collision. Question number 8 calls for an estimation question. Now, this time around, the examiner has shifted the estimation question to question number 8. On the other papers, you will see that this is actually usually question number 1 or 2 in the MCQs paper. So, he says the car is moving at 25 kilometers per hour, and you will notice that the momentum unit has meters per second. So the first thing that you're supposed to do is convert the speed into meters per second. So that will be done by 25 into 1000 divided by 3600. This is what you do in O levels and IGCSE. Okay, this comes out as 6.94 meters per second of speed. Now, a family sedan or a family car has a mass ranging from 1200 to 1500 kilograms, right? So again, this is what generally should be a part of your knowledge as well. Now, since we want to find out the momentum, we're supposed to multiply this with either this or this and just see what you get. So when you multiply this with 1200, you will get 6.94 multiplied by 1200 is basically 8328, which becomes 8.3 into 10 raised to power 3 kg meters per second, right? So a very close estimate of this number would be this one, because we know that it could be either power 3 or could be power 4 at best if we were taking 1500 kilograms, but it can't be more than that. So power 5, power 6 and power 7 were not reasonable estimates. The closest one we get is option A. Okay, all right. So question number 9, again a simple and straightforward question. He says that a ball collides with a wall. First, it was moving at a speed of 8 meters per second to the right. Since moving to the right, we'll consider its velocity to be positive. And after the collision, it moves to the left with a velocity of 3 meters per second. So this is going to be negative 3 meters per second, right? So what is the change in velocity? So final velocity minus initial velocity. So this would be final velocity minus initial velocity, which is plus 8. This becomes minus 11 meters per second. The negative suggests towards the left, and the value suggests the final change. So this is going to be option C. Question number 10 has been repeated on this equation that I've mentioned. I've also seen this question somewhere else as well, probably in AQA or probably in another Pearson and Excel paper. But this question is quite popular, and let's try to solve this. So he says that a bullet pellet is shot into a stationary mass of this one, and then they move together. It embeds itself, this is important, which means that the total mass of the whole system with the block and the bullet embedded in the system will now be 100 grams, right? Okay, so let's try to solve the question. So let's find out the velocity when the bullet hits the block. At what velocity will this block start rising upwards? Okay, so let's calculate that by using the conservation of momentum principle. So we have the velocity or the momentum brought into the system by this bullet, that will be mass into velocity of the bullet being equal to the mass into velocity of the system after the bullet embeds itself. So the mass is 5 grams. 5 gram mass with a velocity of 200 equals to, today the mass will be 95 plus 5 after the collision or after the embedding itself. So this velocity will be V. So this V comes out as 10 meters per second, which means that after the impact, after the bullet stores itself or embeds itself into the mass, the initial speed of the block going upwards will be 10 meters per second. Now, how high this object is going to go? Now, once this system starts moving, we can see that it is under the influence of gravity, right? So we can use the equation of V square equals to U square plus 2AS. And since we're looking for the maximum height or how high above it will go, we can see that if the initial speed is 10, then there will come a time when this will become stationary. And this is the height h that we're looking for. When it becomes stationary, the velocity will become 0. So the final velocity is actually 0 square. The initial velocity is 10 square. The whole system is under the influence of gravity, which is 9.81, but negative because it is deceleration, right? Or it is trying to stop it or hold it back. So when you solve this now, okay, so naturally you might think that this 10 square does not have a negative sign, but this does, right? So what's going to happen when you take this 10 square over there? This will get a negative sign on its own because of mathematics. So this will become a negative 10 square divided by negative 9.81 multiplied by 2 equals to S, which is your height h. That comes out as 5.09, which becomes 5.1 meters. So this will be option A, right? You can also attempt this question. This is a two-part question, and you will see that this question is actually taken from this question from the past papers. Question number 11, very straightforward and simple. He says, which one of them is a couple? Now, for a couple, the forces should be same, right? Now, based on this idea, you reject option C and D because these forces are not exactly the same. They should be either 6 with 6 or 12 with 12. So C and D get rejected based on the first idea that the forces should be same. The second idea is that they should be anti-parallel. Now, anti-parallel means they should be acting in the opposite directions to cause a circular motion, right? Or to cause a rotation. So option A gets cancelled out because of this, because these forces are acting in the same direction rather being anti-parallel. So option B is the right answer because they're acting anti-parallel to each other and they have a perpendicular distance between themselves. So this is the closest definition to a couple. Question number 12 is a bit tricky, but don't worry, we'll try to solve this. He says that this is the system that we have. Okay, fine. He says the system is in equilibrium. As we can see, the rod has what is the magnitude of F to make sure that the system stays in this position. Okay. All right. Now, the uniform rod word suggests that the weight of the object will be at the center. There's 3 newtons is at the center of the rod. Okay. So let's try to solve this. Okay. So by the principles of moment, we can see that the force F is trying to make sure that the rod stays up or it goes clockwise, but the weight of the object is trying to make sure that it goes down or anti-clockwise, right? So both of these moments should be equal to each other, and to find out the components will be more important, right? So if I make the component of force as this one, as the perpendicular component, then this becomes the distance from the pivot up to the length of the rod, right? But there is a problem. The problem is that I need to make sure that the component of weight is also in the same line of action of force as this one, right? So if I'm taking this component of F, which is F sine 30, if you make it from this point, if this is F sine 30, then I need a component that is in the same line of action of force as this one, or as the weight of the object, right? So by geometry, we realize that if this angle is 60, then this angle will also be 60. This angle will be 30. So this component, the green component, becomes mg cos of 30. And this component becomes mg sine 30. But we don't need mg sine 30 because that's not in the same direction of force, or it does not have the same line of action as the line of action of F sine 30. So if this is the length of rod L, then this length will be L by 2 because it's a uniform rod. So the weight will be exactly at the center, right? Now the component that we're going to take is mg cos 30. Do we have a value of mg? Yes, we do, because 3 newtons is already mg. So the anti-clockwise moment, which will be F sine of 30 multiplied by L, which is the distance up to the pivot, equals to the clockwise moment. This is the clockwise moment. This will be the anti-clockwise moment, will be equal to the anti-clockwise moment, which will become mg cos of 30 multiplied by L by 2. Now this is going to be F sine 30 multiplied by L equals to the mg is 3. So 3 cos 30 multiplied by L by 2. L by 2 gets cancelled out, right? So L and L cancels out. We want to find F. So this F is equal to 3 cos 30 divided by 2 sine of 30. When you solve this, this F comes out as 2.6, 2.59 to be exact, 2.59 newtons if you take the full values. So this will become 2.6. Question number 13 is a repeated question from this year and variant. And over there I've also explained to use a shorter method to solve this question, but let's try to make the equation. So this is a question of the final density of the mixture, right? So that will be the average density. That should be total mass divided by total volume, right? And from density, we have density is equal to mass over volume. Since we want to find the mass, volume goes to over there. So the mass becomes density multiplied by volume. So this should be density multiplied by volume plus density multiplied by volume. One density volume is for glycerine and one density volume is for water. Divided by the total volume will be the volume 1 and plus volume 2. So when you do that, this whole answer should be equal to 1.1, which he has given to us, right? Now let's put in the values and try to see what we get. So let's put in the value. So this should be 1.1 equals to density of water is 1, density of glycerine is 1.3. So this, let's say this is 1, and we want to find out the volume of water needed. Let's label this as V, plus the glycerine is density is 1.3 and the glycerine volume is 40. This is 40. Whole divided by the volume of water, which is V1, plus the volume of glycerine, which is 40. Now there is a problem. The problem is that if you try to solve this in terms of algebra, you will take a lot of time, because then you have to take this over there and then you have to perform all the calculations, so on and so forth. What I would recommend is that since you know that after calculating this whole piece of bracket, the answer should be 1.1, how about you make the formula on your calculator and try all the options at A, B, C, and D. For those who have already done this question from past papers would realize that the answer is already probably a part of their memory, which is option D as 80. But let's try the method that I'm suggesting. Let's put in all the values. So in place of V and this V, let's replace 4, then replace 8, then replace 34, and then replace 80. What answers do we get? So if we place option A, the density comes out as 1.27, which is wrong. It should be 1.1. If you place 8, this becomes 1.25. Again, wrong. 34 gives us 1.162. Again, close, but wrong. 80 gives you exactly 1.1. So when we get 1.1, which means that the value of V should have been 80. Now this method actually saves you time. According to me, at least, it saves you time. If you're more comfortable doing the algebra, then you're more than welcome to try that. Question number 14, repeated or similar questions are mentioned. He said that a force resisting the motion of the car proportional to the square of the speed of the car. This is primarily the formula for the drag force, and it's not a part of your course, but we remember, or at least I teach this to students, that the drag force is proportional to the v square, the velocity square of the object. So the magnitude of the force and the speed is 20 at 800, right? So if I make the formula out of this, the drag force is equal to k times v square, then I realize that 800 equals to k into 20 square. K comes out as 2. A constant value of 2. This will help us later. Okay, he says that what's the useful output power required for the engine to maintain a speed of 40 meters per second? If you want to now, today, maintain a speed of 20 meters per second, how much power do you need from the engine? So the formula for power is equal to P equals to FV. And we have made a formula for F, which is kV square. So P is equal to kV square dot V becomes P equals to kV cube. So since we want to find out the power, let's replace all the values. So the value of K was 2 into the speed is 40. Whole cube gives us the answer as 128 kilowatts. So this will be option C, right? Okay. Also, the power is equal to FV formula actually comes from the idea, if you want to maintain the speed, because the speed is maintained, it is a steady speed, it's a constant speed. That means that the forward force from the engine and the backward force from the drag are both equal. Either you look at the question from perspective of the drag, which we are doing right now, which we are doing over here, or you look at it from the perspective of the engine, it will give you the same result because they're both equal to each other. When they are equal, the acceleration is 0, and only then it can maintain a steady speed of this value, right? So it does not matter where you look at it from. So this question is also repeated many times. Question number 15, he says, what's the expression for the efficiency of the system? Now the efficiency calls for the idea that what do you want the system to do? What was your purpose? What was your task or goal or the job that you wanted to do with this? So let's read the question and see, can we find out the job of the question? What was it trying to do? So box of weight, this and this, length of this and this, friction force is this, the diagram shows direction. Okay, fine. The purpose, the task, the job of the slope is to raise the box vertically. So what it is trying to do is raise the box from this level up to a vertical height of this level, either at this location or either at this location. Does not matter what path it takes. It wants to make sure that it moves up vertically. So this was the task. This is the job of the system. So I know that the efficiency output or the output of the system, useful output, should be gravitational potential energy, right? Now, the total input, what have I spent? How much energy, how much power do I need to give to the system to be able to do this? Now, that can be found by the amount of force I've applied, P into D. This is what I have given to the box. So the box eventually moves upwards against a friction force F, right? So the input that we have given to the box is actually in the form of work done, which is F into D. And that F into D is P into this D. So PD will be the input that we have spent, right? And the output is gravitational potential. So that should be mgh. Do we have an h? Yes, we have a vertical height h, but do we have mg? Yes, that is the weight of the object, which is actually replaced as mg. So mgh will be replaced as w into h. So this will be wh divided by pd, which is going to be option D. All right. Okay. Question number 16. The kinetic energy of the particle, this is again a simple question, is increased by a factor of 4. What's happened to the speed of the object? So kinetic energy is equal to 1 over 2 mv square. Since he's asking me about the relationship between kinetic energy and velocity, I will ignore half and m and come down to this proportionality. And then take the square over there. So this becomes kinetic energy under root being proportional to v. He says that the kinetic energy increases by a factor of 4. So under root of 4 proportional to v, v proportional to 2. So the speed would have doubled. The speed would have doubled to cause for a 4 times increase in the kinetic energy. Question number 17, again a simple question of mgh 28 grams raised for 4.6 meters. So this should be mgh. Will be a test of this question or MCQ is that do you successfully convert 28 grams to kilograms, right? So this will be 28 divided by 1000 into g, which is 9.81, into h, which is 4.6 meters. This comes out as 1.263 joules, which is going to be 1.3 up to 2 significant figures. Question number 18 is again a repeated question from the past papers. Some repeated and similar questions are mentioned. He says that a force is applied and the string, the wire, the object extends like this, and then it comes back when it is being unloaded, right? So when the sample contracts, when it is being unloaded, when the forces are being removed, it follows the same path and comes back to the original shape. So this is how the graph actually forms when it is being loaded, when the force is being applied, when springs are being added, when the masses are being added to the system. Now when you start removing the mass, right, it starts contracting again. The spring starts contracting again. So then it follows the same path. If it follows the same path, then there has been no deformation, right? So the behavior will be elastic, but not plastic. You see, plastic means the deformation has taken place. It would have been the case if you started unloading and the object started following this path to come back down again, which means that even when the force becomes zero, when you removed everything, there is still a length or an extension present in the object, which means that you have permanently deformed the object beyond its limit of proportionality, right? So this is how that is going to look like. If it had been elastic and plastic, then this is option A, if this is what you look like. If this is the graph, what it looks like. In another question, in another option. All right. Question number 19. This question requires a bit of mathematics, but don't worry. We're going to single out all the formulas and variables. Let's see. He says we have two wires P and Q made of the same material, increasing force, so and so. And if the material is same, then the Young modulus will be exactly the same. And the graph is plotted. Okay, fine. The wires have the same original length. Again, another hint, but with different diameters. Okay, fine. He says, what's the ratio of diameter of Q to P? Now it's your choice. You pick out any 2 points or any point from the graph so that even the force is same. The points that I have chosen from the graph are exactly this 2, right? So at exactly the same force, Q experiences 1 and 2, P experiences an extension of 3 millimeters. Why am I choosing this point? Could I have chosen any other points? Yes, you could have. You could have selected at 1 and at this 1.5. It would have provided you with the same answer, but I generally stay away from fractions. 1.5 would lead to 3 by 2. So I avoided this because of mathematics. Otherwise, there is no reason for that. Okay, so Young's modulus is equal to stress over strain, which simplifies to FL over cross-sectional area into extension. And if you want to go back to the idea, then this would be force over area divided by X or E over L. When you simplify this, it becomes this one, right? The numerators and denominators separated to each other. Now, since he says same material, and we want to find out the relationship between the diameters, right? So diameters or the diameter is linked with cross-sectional area. So I need to separate the variable of cross-sectional area. And the thing that is different between them is the extension. So A, E need to be separated from the rest of them. So let's replace them over here. So this becomes cross-sectional area multiplied by the extension equals to force length over Young's modulus. Now, how do I cancel them out? Are they exactly the same? Yes, they are. He says the length is same. I don't need to think about length. He says same material. I don't need to think about the Young's modulus. What about the force? Is it different for both of them? No, it's the same because I'm comparing the same point for both of them. So even force gets cancelled out. So what I am left with is that the A dot E factor is actually going to be equal to a constant for either P and for Q. So for cross-sectional area P, extension of P is equal to cross-sectional area Q and extension of Q, because they're both going to be constant to each other, right? Based off this graph. All right. So let's equate them both. We have P being compared with Q. So cross-section area P, extension of P ratio with cross-section area Q ratio with extension of Q. Do we have cross-sectional areas? No, we don't have them. We have the extensions, right? So the extension of Q is 1. So this becomes AQ dot 1 and this becomes AQ dot 3. So this is AP dot 3, right? Now let's replace all of them to one another. We have the diameter of Q with P. So replacing Q, right? Keeping cross-sectional area of Q in the numerator and P in the denominator, we have to bring P over there and this number over there. So this becomes 3 divided by 1 ratio cross-sectional area of Q divided by cross-sectional area of P. So we have figured out by this time that this is what we're going to come down to, right? But please notice that we are talking about the diameter. What's the relationship between cross-sectional area and diameter? So cross-sectional area is equal to pi times r squared, which become pi d squared by 4. So pi is constant, 4 is constant. So this eventually comes down to cross-sectional area being proportional to d square, right? So if I replace 3 over 1 equals to diameter square of Q divided by diameter square of P, there is no harm in that, right? When you take the square over there, this becomes under root 3 divided by under root 1 equals to dq by dp. So we can very clearly see this is going to be under root 3 divided by under root 1. Under root 1 is 1. So that's why it is not visible over here. So it comes down to option C, right? This could have been done in a much shorter way. I agree with that, but I've explained it for everyone that this is the process behind the shortcuts that you might see in other videos or explained by other teachers on other platforms. Okay. Question number 20 is again a repeated question from an old question, very easy. He says, want to find out the spring constant. Now what he has done, why do the question looks very simple, but it is still an A-levels question? Why? Because he believes that you will forget about this extension being in centimeters and the units being in meters. So please be careful. Always look at the units first and then start solving the question. So a force of 6 causes 15 centimeters. So F equals to Kx. So force is 6 newtons causing an extension of 15 divided by 100, or 15 into 10 raised to power minus 2, as I like to write this down. So when you find K, this is going to come out as 40 newtons per meter. So be careful. Question number 21 is from Doppler's effect. He says that the whistle with this student or with this child is exactly the same. It's producing the same frequency. It's not changing. But as a swing takes place or as the child moves on the swing, the frequency heard by the observer will be different, or it will differ. Now he says, when does he hear the highest frequency? You see, if the frequency is supposed to be higher, then the object should be moving towards the observer. From Doppler effect, we know that if it moves away, the frequency heard will be less. If it moves closer, the frequency heard will be higher. So it should be moving towards the observer. That is what we remember from the Doppler effect. Okay. All right. So when the swing is at X, you see at X and at Z, the object or the student has to become stationary momentarily, because either it's going to come down again or it is actually come back from the forward position and is maintaining that point to move forward, right? So it maintains a motion at this point, it maintains its position at this point, then comes back and stays at X momentarily and then goes back to Z. So at these two locations, since the object is not moving, since the swing is not moving, the frequency heard will be constant. It will not be observing Doppler effect. So option A and D are cancelled and they can't be considered even to begin with. First, we figured out it should be moving towards the observer. He says moving away from the man. This is incorrect. It should be moving towards the man. So option C will be the right answer. Question number 22 is interesting, and it's a new question, you can say. A loudspeaker is playing in the room, and the width of the door is 0.8 meters. So the door is, or the gap of the door is 0.8 meters. Okay, fine. He says the speed of the sound is 340. He says, where will it experience the most diffraction as it passes through the doorway? Now we understand that for the diffraction, for maximum diffraction, the lambda should be equal to the gap width, right? Or at least the lambda should be smaller than that, right? If it is greater than the gap, then there will be no diffraction or minimum diffraction or almost no diffraction. So based on this idea, what you can do, there are two approaches to this. You can use V equals to F lambda and use velocity as 340. F, since these are all frequencies, right? These are all Hertz frequencies. You can use the wavelength of the door or the gap of the door, because if these are the sound waves, these are the wavelengths, then by the theory, it should be equal, right? So when we find out the frequency over here, this comes out as 425 Hertz, which is going to be 4.3 into 10 raised to power 2, up to two significant figures as option D. You see, this is approach number one. Let's go to the approach number two. What could you have done alternatively? You could have calculated the wavelength for each stage if this was the frequency. You again, by using V equals to F lambda again and again, by putting these frequencies in, you will get that the wavelength of the first one, or the first question, first option, is 141 into 10 raised to power 3 meters, which is too long, which is too high. It can't be possible. Then for the second one, it is 425 meters, which is much greater than 0.8. It's not possible. For the C option, this is 1.259, again much greater than 0.8. It's not possible. For this one, we get 0.79, against losing ourselves in the decimal place or the rounding off. So since this is equal or less than the gap width, you will experience the maximum diffraction at this point. So option D will be the right answer, right? Question number 23 is from CRO. He says that the speed is given and the distance, which is going to become the wavelength. So what is the wavelength over here? He says that the amplitude rises at X, then to a minimum, and then rises once again up to Y. So it looks like that if we had made a compression or refraction or a compression wave for a sound wave, or for a stationary sound wave, it should be node, antinode, node, antinode. If this is what the wave looks like, for the sake of example, right? So the maximum amplitude is heard at X, let's say, and then it rises to Y again at this point, which would be at this location, right? Which will be Y at this point. So how much is this? What is the distance between them? So the distance between X and Y is actually lambda by 2. It's half a wavelength, right? So if I wanted to consider the full wavelength, then I'll have to double the distance. So if this is 33, 2 goes over there, so lambda becomes 66 centimeters, right? Okay, so V is equal to F lambda, right? So this is 330. F, we want to find out the frequency. Why? Because frequency is equal to 1 over T, or T is equal to 1 over F. We need this because we want to find out the time base. We need to find out the time represented on the screen. So lambda is 66 into 10 raised to power minus 2. Don't forget the centimeters. So F comes out as 515 Hertz. So T is equal to 1 over 515, which is 1 over F. So T comes out as 1.9 milliseconds, which is approximately 2 milliseconds of time, right? So let's count the number of boxes of each option. Where do we find it? We need a complete wave in 2 milliseconds. So in option A, he says that one box is 0.5. So 0.5, 1, 2, 3, 4. This gap becomes 2 milliseconds according to this graph. But we need a complete wave a complete wave in a total time of 2 milliseconds. It can't be more than that, but this is only half a wavelength, which is wrong. Let's try option B. So from this point to this point, we count 1, 2, 3, 4 boxes, and 0.5 multiplied by 4 is actually 2 milliseconds. So yes, we have a complete wave with a crest and a trough, a complete wave within a time frame of 2 milliseconds. This seems to be the right answer. You can try this for option C and D. You will not get the 2 millisecond gap. Okay. Question number 24 is repeated again for polarization's sake. It was repeated as question number 27 in February-March 2024 P12. This was repeated again at question number 21 February-March 2023 P12. You can see it's a favorite question of the examiner. Then question number 23 October-November 2022 P12. It's about polarization, which can or cannot be polarized. Only transverse waves can be polarized. Longitudinal waves cannot be polarized. So he says, what cannot be polarized? Radio waves, it's a transverse wave. It can be polarized. Sound wave, yes. This is what cannot be polarized because it's a longitudinal wave. Longitudinal waves cannot be polarized. Ultraviolet, again, it's a transverse wave, cannot be polarized. X-ray, again, transverse wave cannot be polarized. All these radio, ultra, and ultraviolet are actually from the EMT spectrum, electromagnetic spectrum. They are all transverse waves. So one way or the other, he actually tries to nudge you in the same direction. Whenever you see polarization, it cannot take place for sound waves. Simple as that. Okay. All right. So question number 25, a guitar string is plucked. He says, what statement describes the resulting wave? Now we know that the guitar string produces a stationary wave, but in its own length, in its own string, it's a longitudinal wave because it's sound wave, right? So a transverse wave on the string, right? So if this is the string between two waves, between 2 points on a guitar, you pluck it from a certain point, it will be a transverse wave, right? So a transverse wave go to this point, gets reflected back, and there will be a stationary wave set up between the 2 points. That is how stationary waves work. So it starts with a transverse wave, which causes a longitudinal wave because that is sound, right? So option C will be the right answer. Question number 6 calls for the gradient, no problem. So if you want to find the gradient, that will be change in y divided by change in x, which this is y and this is x-axis. So this should be sine theta divided by lambda. We need to find something equal to this. So let's go for the diffraction gradient formula, which is n lambda equals to d sine theta. Let's replace all the variables in the situation. Now small d is not given to you, but something else is given to you in its place, that is n lines per meter. Now this means that d is now equal to 1 meter divided by capital N, which becomes 1 over n. So I'm going to replace 1 over n over here. So this becomes n lambda equals to 1 over capital N sine theta. Now since we want sine theta over lambda, let's make that on the right hand side. So let's bring lambda over there and n over there. So this becomes capital N multiplied by small n equals to sine theta divided by lambda. This looks like the gradient, and now we can see that it's equal to capital N multiplied by n. Question number 7 suggests that we have an open tube from both ends. So it's a tube going to look like this, right? Just a moment. Okay, so if the pipe is open from both ends, then that means that there will be an antinode and antinode at this point, right? So let's make a wave that represents such a scenario. It says that there are 3 nodes. Okay, so at the center there will be 3 nodes, like this, and like this, and then like this, and like this. So something like this will be made inside the tube, because on the open ends there needs to be an antinode. So then he says how many antinodes are there. So this is one antinode, antinode number 2, antinode number 3, and antinode number 4. So there will be 4 antinodes in the current scenario. Question number 28 is a repeated question again. He says interference fringe pattern, screen is at 1 meters, double slit illuminated by yellow with 600 and at a distance. At which distance? So it's asking about D. Double slit would be interference pattern of the same separation x observed when the wavelength is 400 nanometers. Okay, so we can see the formula, that is AX equals to lambda D. The comparison that he wants is between lambdas and D's. The fringe separation, he says it needs to be the same, so X cancels out, and the distance between the slits is also same, so it cancels out. So we have lambda equal to D being constant to lambda equal to D. So for yellow being equal to another situation of lambda of the blue light, right? So let's replace the values for yellow and blue. So for yellow, we have 600 into 1 meters as given in the question equals to 400 into D. We don't know this, right? So when we solve this, we find out that the answer comes out as 1.5, which is option D. And this was repeated exactly the same in this year and variant. Okay. Question number 29 is again a fact-based question. He says potential difference. What is the definition for that? So that is voltage is equal to work done by charge, which is joules per coulomb. So it is energy transferred. Yes, the first statement is right because it is joules. Per unit charge is right. Per unit current, no. Distance, no. Time, no. Option A is the right answer. Question number 30 requires a bit of calculation, but if you have practiced these questions many times, you may not even end up doing the calculations. You will just know the answer by instinct. But let's try to solve this. He says when the switch is open, that means that this circuit does not exist. Let's simplify this. This circuit, when the switch is open, does not exist. If this does not exist, then it becomes a very simple circuit to look at, right? So how to observe this? So we need to find out the EMF of the battery. Now, if there is a negligible internal resistance, good God, the question becomes even simpler. So if the current in X at this situation is 4 amperes, which means that 4 amperes of current is flowing through, then according to V equals to IR, V is E, which I want to find out. Current is 4 amperes multiplied by the resistance, which is R. This becomes 4R. So EMF is actually 4R. It could be anything, but I don't know that right now. Okay, so let's erase this. Now he says that when the switch is closed, what will be the value? So let's bring the circuit back into the situation and let's draw a line over here which represents the circuit is connected now. Okay, let's remove the situation from switch from this position. Now if the circuit is connected like this time the X reads what value and what value will be read by Y. So what you can do is solve it in a very simple way. You see, both resistors are in parallel to each other, right? So there will be some current over here and there will be some current in the other branch. Let me make it the other way, because the positive causes the current to emit. So if I were to find out the current for this branch, it will come out as 4 amperes as previously found out. But if you're not comfortable, you can do this again. So since they are in parallel, the voltage available to both resistors will be the same. So E equals to IR. E is 4R equals to current we don't know, and R is the resistance of that branch. So R cancels out, we're going to get I equals to 4 ampere. So across this branch we have 4 amperes. What about this branch? So since the voltage is exactly the same, E equals to IR and E is 4R equals to current, which is the second branch current. Now the resistance of the second branch is 2R. So this becomes R cancel with R and 2 cancel with 2, 4. This becomes 2 equals to I. So this branch has a current of 2 amperes, right? So let's look at what option gives us Y as 2 amperes. So Y should be 2 amperes. So it's going to be option C. But does ampere X show 6 amperes? Does it show 6? Yes, because this 4 and this 2 when get gathered around in this branch will become 4 plus 2, 6 amperes. And the same current goes over here, then gets divided again through these branches. So X will read 6 amperes. So it should be option C. Right? Okay, this question for IV characteristics requires an understanding in terms of gradients and in terms of instantaneous points. Now he's asking us for the greatest resistance. Which one of these 4 components could be a filament lamp, could be a resistor, could be a metallic resistor, could be carbon film resistor, it could be any of them. So which one of them from A, B, C, and D is going to produce the greatest resistance when the potential across all of them is V1? For the sake of example, let's assume that this voltage is, let's say, 10 volts, for the sake of example. Now at 10 volts, component D is maybe consuming this much current. Component C is consuming this much current. B consumes this, and A consumes or requires this much current. If you were to calculate resistance from Ohm's law at these locations, the formula goes something like this. So resistance is equal to a ratio of potential difference with the current. Now, we can see that the voltage remains constant, which for the sake of example, we can assume it in this way. Now, if we are looking for the greatest resistance, that means that the current through that component at the same voltage should be the lowest. Now, by that logic, we can see that the minimum current is actually being drawn by option D, or the component D. And the maximum current for this given option is being drawn by component A. So for this question, the maximum resistance would have been for option D component, because even at 10 volts, it is drawing the smallest amount of current. Even if we give it values, let's say this is 1 ampere and this is, let's say 3 amperes, this is 4 and this is 5 amperes, we can still see that for the highest voltage, and even for this voltage, the option D component only manages to draw just 1 ampere of current. So for this question, option D would be the correct answer, right? Some students may fall towards the answer in terms of the gradient logic. Now, the gradient of this graph would look something like this, that y, or change in y divided by change in x, which is going to be equal to current divided by voltage equals to, which is the inverse of the resistance. This could have been the option, this could have been used, but we are looking for a specific point in time, right? And for that, this logic does not hold true. This may have been true for the gradient function when you were looking for a change in terms of the whole curve. If you were, let's say, discussing option D only, how does its resistance change over the course of its life? Then you may have used this logic, but this is only for one component. How much current change occurs when you change the potential difference. So the change logic only applies for one individual component when you're talking about it. A similar question you will find in October-November 2005 P1 question number 34. It also puzzled the student at that point as well. But in this question, the question is a bit different. He's asking you about the smallest resistance. Now, what I've explained you again, this is just one component. This is in terms of conducting through the liquid itself. Now, he's asking you at what point in time, at which point in time will it have the smallest resistance? Again, if you go by the logic of change, you will land at the confusion that should the change be at this location, it will be an infinite resistance at this point because the gradient becomes practically infinite. But if we go towards the instantaneous logic that we've used for just the question as previously, that is V over I, you would realize that at point C, it consumes moderate voltage and produces or calls for moderate amount of current, right? But at option D, we can see that the voltage increases from a small value to a very large value and only produces a very small amount of change. So in this region, the resistance has changed. The delta R is very large. It's too huge of a resistance. He's looking for the smallest resistance at an instant. Now for these questions, another logic that you will find in the marking schemes and in examiner report is called drawing a line from the origin to that point. I will show you that answer in the examiner report of this question as well. So if you draw that line from the origin to that specific point, let's say up to option A, this is what the line looks. For option B, this is what that line looks. For option C, this is that line. And for option D, let's choose a different color for that. It looks a bit like this, which is somewhere in the middle, probably. Let me draw this again, which is somewhere in the middle of option A and B. Now this straight line being drawn from the origin employs or is actually asking you to draw the same conclusion. Choose instantaneous values. Now, since we're looking for the smallest resistance, the value of voltage should be considerably smaller and the value of current should be considerably larger. We can see from this line, if we were to look at from this scenario, the line with the largest gradient would produce the smallest resistance, right? Because it's the inverse ratio. So the gradient, which is change in y divided by change in x, equals to current divided by voltage equals to 1 over r. If you're looking for the smallest resistance, smallest r, then this whole ratio should be the largest possible answer. And it can only be done when it produces, let's say, that the current is high, let's say, and the voltage is low, right? So the divider, the numerator should be a smaller number and the denominator should be a larger number. If you look at it for option A, small current relatively, but at a very high voltage. B, moderately high current, but moderately high voltage as well. Only C, we can see that the ratio almost looks as 1 to 1. The amount of voltage or the amount of distance covered in this direction, the amount of distance covered in this direction looks almost equal, which is not disproportionate. So again, by choice, by calculation, or by sheer measurement of the distance, we can give them random values. And the smallest resistance comes down to just a single point, that is going to be option C. If you go by the gradient logic, then you will find the same gradient almost over here and almost over here as well. Then it puzzles you again. So to choose an answer for this question, you should go for the point logic, not for that. But if it was for an individual component, just one, and he asks you about the trend across the board, he's asking you about the trend in terms of theoretical question, then definitely you can go for the gradient idea, that this is the inverse of that, right? Okay. In the first part, he gives you the variables. He says cross-sectional area is A, free electrons is N, current is I, drift speed is V. So let's replace all of these variables in the drift velocity formula, which will be NAQV. Okay, fine. He says the second wire has this area, has 2n number of electrons, and has 2V the speed. What is the current? So let's replace all the variables again. So 2n, cross-sectional area is the same, right? No, that is 0.5. Cross-sectional area is 0.5a multiplied by the charge q multiplied by velocity, which is 2v. So when you're done with multiplication or multiplying all of these things together, this comes out as 2 times I, or the 2 times the current I. So this will be 2I. And where do we get I? We're going to combine NAQV in replacement of simple I. Okay. Question number 33, repeated and similar question in these locations. He says, what is not a possible charge configuration? This concept is known as quantization in your past papers or in your syllabus. What he's trying to say is that the fundamental charge value is 1.6 into 10 raised to the power minus 19 coulombs. Now, it cannot be smaller than this, or it cannot be any number greater than this, but other than an integer value. So it's not possible that we get a charge that has a value of 1.5 q. It's not possible, right? It will always be a multiple. Either it's going to be 1q, 2q, 3q, 4q, up to an infinite q, but it can't be 1.5, 1.6. So in order for us to check this, what we can do is divide every option with 1.6 and see which one of them does not give us an integer value. So if you divide 4.8 with 1.6, I'm ignoring the power 19 because it's exactly the same for all of them as well. Okay, so 4.8 divided by 1.6 gives me 3 times q, which is a plausible answer. It is a possibility. So 2.4 divided by 1.6 gives me 1.5 q. This is not possible. This can't be done. 1.6 is 1.6, so this will be 1 q. 3.2 divided by 1.6 is 2 q. This is also possible. This is also possible. B is not possible. It can't be an integer. It cannot be a number other than an integer number or integer value. Right? And you can ignore the positive and negative sign, does not matter. Negative is the negative charge, the electron, positive is the positive charge carriers of the protons. Does not matter. Question number 34. What is Kirchhoff's first law? So first law is about the current entering a junction will be equal to the current leaving a junction. So he says it's about current. Okay, so the first option A and B are about the first law. When he discusses electromotive force, this is going to be about second law. So we can ignore option C and D for this question. He says, as a consequence of conservation of charge, yes, conservation of electrons, the number of electrons entering a point will be equal to the number of electrons leaving the point. They can't vanish out of the blue. Consequence of the conservation of energy, no, energy is second law. So answer for this question will be option A. But if this question was for second law, then that would be option D. Electromotive force and potential difference in a loop are the consequence of conservation of energy or work done. Okay. Work done by the battery will be equal to the energy consumed by the electronic components. Question number 35. This is again a shortcut question. He said that two resistors R and R connected in parallel. The value of R is less than R. So R is less than capital R, which means it's possible that this is 5 ohms and this is, let's say, 100 ohms or 10 ohms or even for say 6 ohms, does not matter, but it's less than that. Okay, he says, what's going to be the combination? What's going to be the answer for this? Which statement about the system is correct? It is between R and R? No. It is equal to R plus R? No. It is greater than? No. It is less than R? Yes, this is correct. This is true. If you have done parallel circuits in complete detail, you will realize that the parallel combination resistance is always less than the smallest component. For example, if this was 5 ohms and this was 100 ohms, I can with absolute guarantee predict that my answer for the parallel combination will be less than 5 ohms, less than the smallest component, right? If you want to try this, you can try this with any value right now, here and now. Let's say 1 over 5 plus 1 over 100. If you finally solve this, I have a shortcut for this, which is for two resistors, product over sum. So this will be 5 multiplied by 100 divided by 5 plus 100 gives you 500 divided by 105, which is 4.76, which is less than 5. I told you, it's an absolute guarantee that in parallel combination, the overall answer, the total resistance, will be even smaller than the smallest component. It's not only true for two resistors, it's true for any number of resistors. Let's say you have 3 resistors in a combination like this. This is 2 ohms, this is 5 ohms, this is 10 ohms. I can predict right now that my final answer will be less than 2 ohms. You can try this. So this product over sum only works for 2 resistors, it's not applicable for 3. So I'll have to go for the longer method. 1 over 2 plus 1 over 5 plus 1 over 10, then whole inverse for the total resistance. So this would be 1 over 2 plus 1 over 5 plus 1 over 10. And this is 5 by 4. This is 1.25. The answer comes out as 1.25 ohms. Again, less than 2 ohms. So for parallel combination, this is an absolute guarantee that the overall resistance combination will be even less than the smallest component. In this situation, the smallest component was small r. He says himself that r is less than capital R, right? So I can predict that. Question number 36. He says that identical resistors, okay, thank you. Which resistor dissipates the most power? So this is positive and negative. So if, let's say, we assume that the current is I, the current goes through this branch and then divides. We know that in the branch B and C, there are 2 resistors. So can I say that the current in comparison to this branch and this branch, the current in B and C will be less than the current in D, because D is a single resistor and B and C are 2 resistors. So when the resistance is greater in parallel combination, the current decreases. More like a traffic example. If you're moving on the road, you will choose a road that has less traffic. So the electrons choose a path which has less resistance, which has less traffic, right? So the current, let's say, if this is 1 ampere or 1 I, over here I can say that this is 0.3 I, and over here this will be 0.6 I, at least double than that of the current of the other branch. Because if there are 2 resistors, current will be half. If there is 1 resistor, current will be double in comparison to the 2 branches. Right? So now I can see if the resistance are identical and I have a formula for I square R, I want to find the most power. Do I have a control over the value of R? No, I don't, because they're all identical. This is R, R, and R. I can't change it. If I want the highest power, I should be looking for the highest current. Where do I see the highest current? You see, in these 2 branches, the current had to divide, and naturally, when the current divides, it will be smaller. Right? It will be smaller than the main branch. It divides over here, divides over here. It will be less than the main branch current. All right. So the maximum amperes or maximum current experienced by any resistor in this combination is resistor A, because it gets the main current from the battery. It has the highest value of the current, so it should be option A. Because when the current comes over here, it has to get divided into 2 branches. As it divides, the value of current decreases ever so slightly or ever so more, so the value of P will also be less. I can't control the value of R, so my argument lies on the value of I. Where is it going to be the greatest? Question number 37 is from memory. He says there is a beta positive decay. So what happens with Y? Proton number of Y, it should be decreased by 1, because for beta that is 0 plus 1. So this number or the proton number of Y will be less. So that will be Z minus 1. If this was A and Z, this will be Z minus 1 or Z minus 1. This will be option A and B. It can't be C and D. It would have been C and D if it had been beta negative decay. And with the beta positive, we understand that the only particle emitted due to this process is a neutrino. right? They belong to the lepton family, so B option will be the right answer. Again, based on memory. He says, what particles are the fundamental particles of the hadron family? Now, hadron family has two more families. The first one is baryons, which have 3 quarks, and they are protons and neutrons. We know this from memory. The second family is mesons, and they have 2 quarks. One of them is a quark and one of them is an anti-quark. This is specialty for mesons, right? So he says hadrons belong to which family? So they need to have quarks. Leptons are separate family. They have electrons and neutrinos. Nucleons belong to baryons, right? And photons are electromagnetic spectrum particle of nature, or electromagnetic radiations energy particle. So quarks is most likely for hadrons. 39, this is an interesting question. He says that X decays by alpha and beta and becomes Y. He says how many alpha and how many betas are going to be there. So the first thing to predict alpha, we have alpha as 4, 2 and beta is 0, -1. First, we can very easily figure out how many alphas must there have been decayed, right? So it goes from 218 to 210. So 218 to 210, there is a difference of 8 mass number or 8 nucleon number for an alpha particle. Now, since beta has a 0 value, beta cannot do this. During decay, beta could not have done this because it has a 0 over there. Only alpha has a 4. So only alpha can decrease the number in the nucleon number spot. So 8 divided by 4 gives me 2 alpha particles, or 2 alpha particles must have done this or brought this from 218 -4 to 214, then -4 again to 210. So I'm very sure that alpha particles are going to be 2. Then we come back to the beta particles. Now we know for sure that 2 alpha particles have gone through by it. So if I had to look at the lower number, which is 84 and 83, so from 84, if we emit 2 alpha particles, -2, this becomes 82, then again -2. Because of alphas 4, 2, this will become 80, right? Now we have 83. It should have been 80. But if it is 83, that means that there must have been 3 beta particles, because the beta particle, due to its -1, it adds a number in the final proton number. So 81, then 82, then 83. So it is only done by beta, beta, and beta. So there are 3 betas who have done this, or who might have done this. So this is going to be option C. Question number 40. It says, which statement is true about the radioactive decay? Neutrinos are always emitted during no. Alpha decay does not causes neutrino decay or neutrino emission. The alpha emitted from radio no. Continuous energy. This statement is for beta particles, not for alpha. The beta particles emitted have, yes, they do have a continuous range. And why do they have a continuous range? Because beta particles share their energy with neutrinos. This is what led to the discovery of neutrinos. They believe that if alpha has a continuous energy spectrum, every particle has half mv squared kinetic energy, then why is it not possible for beta particles? Beta is also a massive particle. It should have the same energy. But they, all of them, let's say, if this is a radial decay, if this is beta, and this is beta, all 3 of them should have the same energy, but they don't. Because some of them are actually emitting neutrinos, antineutrinos, and so forth, based on beta positive and beta negative decay. This discrepancy led to the discovery of neutrinos, that if the energy is not same amongst all of them, then there must be another particle that is sharing that half mv square of kinetic energy, right? That is why the continuous energy range point is only special for beta particles, beta negative and beta positive. The proton number of nucleon decreases by 4. No, the proton number is AZX. This is the proton number. This decreases by 2 because alpha is 4, 2. It causes a reduction of 2. So this is also a false statement. Only C is the correct answer in this situation.